Good afternoon, everyone. My name is Prashant Kumar, and welcome to the webinar number 17 of the Reclaim Network. So just to say very quickly that the Reclaim Network Plus is one of those networks which are funded by the UKRI from 3 councils, which includes EPSRC, NERC, and AHRC. This is led by the Global Centre for Cleaner Research at the University of Surrey with the colleagues from the UK Centre for Ecology and Hydrology, Bangor, Warwick, and Bath. So the network has got our network fellow as well as manager, and it has grown actually quite a lot since it started around 18 months back. So we got around over 500 members. They're representing almost around 50 countries. This webinar series we launched actually in the very beginning. So as I said earlier, it's number 17. So we had the last one where we heard from the colleagues from the Chinese Academy of Sciences in China and University of Bath. So they were very interesting webinars. And that recording is available on our YouTube channel, and we'll post the link in the chat box if you wanted to have a look or you wanted to share with colleagues. So the whole idea of these webinars is to share the best practices and facilitate the knowledge exchange and bring in colleagues actually from academic or non-academic sectors. So there has been a diversity of the speakers coming from a very different background, but they all have a similar sort of goal in terms of either using green, blue, grey infrastructure for making the vulnerable living spaces healthy and sustainable and resilient. So this usually happens between 12:30 to 13:30 every Wednesday, every month. And the speakers are we picking up in two ways. The one are the invited speakers, like we have two of them today, and or you can just fill this form. There is a barcode there. We will also put the link in the chat box where you can show your interest, and then we can invite you to be the speakers in the future webinars. Today, it's a pleasure to have two of our speakers. Before I introduce to them, I'll just try to give you some of the housekeeping notes. So this webinar will be recorded, and you can see those webinars later on. So we will send you the link. If you are a member of the network, you might be receiving them as part of the newsletters as well. Or you can go onto our web, the YouTube channel, and you can see them there. Each of these, the talks are going to be 20 minutes. So, and we'll go one after another. So your questions and answer session, we will do in the end of these two webinars. So my request would be that please use the Q&A box you can see on your screen. Write your name and affiliation and the question you may have for any of those speakers today. And towards the end, I will read it for you to our speakers, and they will answer those questions there. So before further ado, so we got our first speaker, Dr. Michael Hutchins. He's a water quality modeler based in the UKCEH in Wallingford. He's interested in multiple benefits of nature-based solutions that in the urban environment. He's participating in the REGREEN project and leading the DeSCIPHER international research project. His own contributions have focused on identifying the levels of aquatic benefits that can be achieved from nature-based solutions. He has then gone on to incorporate this evidence base in model applications, which can support assessment of policy relevant scenarios. And our second speaker is Dr. Janice Scheffler. So I will introduce her in more detail once we have our first talk completed. So without any further ado, I would like to pass on to our speaker for this talk. Over to you, Michael.
Thank you very much, Prashant. I'm setting up my screen share, so hopefully that's all working okay. Is that in full screen mode? Just to double check.
Yes.
Yes, excellent. Okay. As I say, thank you for the opportunity to speak to you all today. I'm going to present some findings from two international collaborations between European and Chinese researchers, the REGREEN project and the DeSCIPHER project. And in particular, we'll be looking at some results for three cities, for Birmingham, for Aarhus in Denmark, and for Oslo in Norway. Today, I'm going to focus predominantly on the science and on the science which underpins the assessment of benefits of urban woodland for mitigating a range of the issues that we have connected with flooding and pollution in urban areas, water pollution. I'm not going to focus much at all on the societal, the governance and the financing side of things. We've been doing that a lot in the projects, but that won't be covered today. Now, I think you're probably well versed on the role of nature-based solutions in sustainable management, so I'll go through this quickly. But the graphic here basically sort of highlights from large surveys of NBS establishment and shows the importance and the prevalence of tree planting in many NBS typologies, obviously most commonly in the establishment of parkland in urban areas. So trees and aquatic benefits. Well, a lot is known about the links between woodland and water resources in rural environments. Much research done over many years, but we really need to consider how much evidence there is and what the evidence is in urban environments themselves. And it's important because the setting may be quite different. So physiological factors can be affected. For example, rooting systems may be constrained. There may be greater stress and exposure to pollutants from various media. And the urban surface and the urban soils obviously has a specific influence on how transport to surface water courses and to groundwater of pollutants may be affected. So in reviewing the literature, and the first part of the presentation, we look a lot at literature evidence. It rapidly became clear that there's a lot less evidence in urban environments than there is elsewhere. So to start off, we looked at hydrological benefits in terms of the reduction in runoff of urban tree planting, and we undertook literature review and a meta-analysis which identified many studies that largely addressed small-scale effects. And we've generally found that the benefits are quite evident compared, if you compare urban woodland areas to impermeable surfaces, but also considerable benefits compared to mixed urban fabric. So buildings and grass, land and gardens, considerable benefits in terms of runoff reduction, which is encouraging to see. On the right of this slide, a very different approach to looking at quantifying benefit. We looked at use of the widely used process-based SWIM model and undertook scenario analysis. And here's an example in a small catchment area in Aarhus in Denmark. It focused on the standard storm events, and it showed the huge benefit that the existing retention ponds are making in terms of reducing peak flows. What it also showed is in a number of scenarios run, it showed that establishing trees will also give extra benefit, or should give extra benefit that's comparable to the sorts of benefit we can get from other nature-based solutions, such as establishing green roofs or establishing permeable paving. That was hydrology, and then we moved on in a similar way to look at water quality benefits. And here we basically, in a review exercise, we focused on nutrient pollution and eutrophication. And we rapidly found that the evidence that we collated was kind of split into two groups, into plot scale studies on the one hand at a small scale, which included effects in soil waters, groundwaters and runoff, and included engineered systems. And on the other hand, larger scale catchment scale studies, which are mainly rivers. And meta-analysis we undertook, we standardized and summarized the findings in each group. And the pie charts and the box risk plots show that in the majority of studies, we saw clear benefits. This was especially so at the plot scale for total nitrogen TP, total TN and total phosphorus TP. But there's considerable scatter in the findings as well, considerable uncertainty. Two other main issues arising from the research showed that leaf litter is an important an important issue to consider. So leaf litter falling on impervious surfaces can be a source of rapid transfer, in particular of particulates and of phosphorus to water bodies. So abrasion and wash off are the kind of important processes here that we need to mitigate against. And secondly, a number of studies looking at riparian trees, which have a complex influence, and I'll come back to that a bit later in the talk. So that's the first two elements, and then we moved on to look at aquatic biodiversity, and we undertook another systematic literature review and a meta-analysis of included 32 articles in this particular case, and these were for in the case of aquatic macroinvertebrates. So what we looked at here was addressing questions of whether the prevalence of trees was positively correlated with biodiversity. And secondly, what about the location of trees? Is it important that they are within the urban area or not important? So in general, the findings were that to the first question, we saw a positive correlation indeed. That was generally the case, with some uncertainty, of course. And the second question, it seemed that there wasn't a locational factor really coming out strongly. So little substantial difference, for example, between studies where looking at the impact of riparian woodland and that looking at the impact of woodland more widely within a contributory basin, a contributory catchment area. There are many other studies that gave uncertain findings. Benefits can tail off at high levels of woodland. Habitat modification is an important consideration as well. And all these studies there's a whole variety of different bioindicators. So this in itself introduces uncertainty. And it's difficult to assimilate all the evidence when you have this kind of situation. So as well as literature review, we also undertook a statistical analysis, which we did using a nationwide data set for England, a statistical analysis of biodiversity, and this was done for macroinvertebrates in a selection of urban rivers across England. The data set had been filtered, so we only considered small catchments, highly urbanized catchments, and catchments which didn't have wastewater influence. Now, this is very important because this is a really difficult filtering process to achieve, to analyze data, and just basically to focus on the importance and the influence of diffuse urban pollution and the urban fabric, basically. So what we found from this analysis was that it showed the influence basically of land cover, different land cover types, and the influence of habitats. And the benefit of woodlands we found to be stronger in these urban catchments than the benefit of grassland. And the benefits far from the rivers, not just the benefits from the riparian woodland, were quite apparent, which kind of mirrored what we found in the literature review. Urban land use and sparse land are detrimental to macroinvertebrate diversity. So urban land use, the built environment, that wasn't a surprise that gave detrimental effects. But it was very interesting that sparse land, which might include derelict land or building sites or land that's basically not being used apparently, ex-contaminated land, even if it's in small quantities, is really quite detrimental to the biodiversity apparently. We've also seen improvement in time, as you can see from the time series plots in the middle of the slide. And this improvement has coincided with measures to reduce pollution in urban areas. We see lower concentrations of heavy metals in our urban rivers now than we did 30 years ago, for example. So that was the work on these three sort of aspects of aquatic ecosystem health. And then we went back to consider specifically the case of riparian tree planting, and to consider how we can use our modelling tools available to us to to make some insights about benefits from riparian tree planting in terms of how they can improve the situation of river eutrophication in urban areas, and how these benefits they might vary from one city to another worldwide, and how can we sort of compare and transfer knowledge worldwide about this particular aspect. So what we did here is we basically used a one-dimensional eutrophication model, a process-based model called Questor, which is a CEH model, and we standardized the way that the model was set up between cities. So we isolated the differences between cities that are not due to basin size and local factors, so local channel hydraulic factors essentially. And to do this, we needed to cover the range of river types, so hydrodynamic types. So we ran the models for three types: for a slow flowing river, which might represent a river that's impounded with dams, heavily modified, typical rivers in urban areas, and then medium and faster flowing systems, perhaps more natural streams, which also were found in urban areas. And in doing this standard approach, we overcome some of the demanding kind of locally specific data requirements that the model needs, and is a barrier to actually applying models in a widespread way between cities and between countries. So on the right, we have 5 graphs, and these show results from 5 Water Framework Directive related summary indicators of water quality. And we did the analysis for Birmingham, for Aarhus, and for Oslo. And in each graph, the x-axis is a simulation of without any riparian tree coverage, and the y-axis is including 10 kilometres of riparian tree establishment. So when the points on the graph plot away from the one-to-one line, then tree planting, we can determine, has had some kind of effect. And what we see here with these plots is we see beneficial effects. If we look at the top 3 plots, we see tree planting decreases water temperature, which is something we want. It decreases algal biomass, chlorophyll concentrations, so decreases incidence of algal blooms, and it increases the levels of oxygen in the rivers. The bottom 2 plots show nutrients, so nitrate and phosphate, and we show a slight decrease in the biotic uptake of nutrients under shaded conditions. So these results, they very much also show the sensitivity of water quality to hydrodynamics. And this is especially the river hydrodynamics, especially the case for dissolved oxygen and for chlorophyll. And these differences can be bigger than the between city differences. Between city differences, it shows that the Birmingham rivers tend to have higher nutrient concentrations. In Oslo, the rivers are cooler, but they have the biggest benefits with riparian tree establishment in terms of suppressing algal blooms. And the biggest temperature benefits were seen in the Aarhus case. So a little bit more on this exercise. We're interested in looking at whether the benefits increase progressively from, or how they increase progressively from 0 to full tree cover along a river. And I mean, the reality is tree planting programs are likely to involve small amounts of planting. You know, perhaps a quarter of our urban rivers might undergo planting. So the predicted benefits for 3 indicators are plotted here. Those the oxygen, water temperature, chlorophyll, and the benefits depend on the hydraulics, they depend on the city, and they depend on the existing extent of riparian tree coverage. So, for example, a 25% increase will give greatest benefit for chlorophyll when present-day tree occupancy is relatively high, but the greatest benefits for temperature and DO are more likely when the present-day occupancy is low. This is all very important because deoxygenation, dissolved oxygen in rivers, in rivers which are warming with climate change, is a very widespread global problem which is accelerating. And a recent study across continental evidence, continental data sets, nature climate change is showing this is especially the case in urban areas. So finally, in the presentation, I want to look at aquatic benefits and in the context of other benefits. And firstly, we've done some research conceptually looking at the importance of co-location of pressure, nature-based solution location, and receptor. And we can see here on the right the blue graphs that the benefits can be directional. We can have hydrological benefits which go downstream, and these can persist far from the nature-based solutions. In contrast, we might have much benefit, for example, for tree planting for noise reduction, for mitigation, but those benefits might be quite localized and less pervasive than for others. Also, if you look at the bottom, the relationship between size of nature-based solution and benefit is not always linear, and often we can anticipate there will be saturation effects. So, for example, very large green spaces may become inaccessible for people to derive health and access benefits from them. Finally, multiple benefits of urban woodland. We've also looked at setting up conceptual frameworks for assessing multiple benefits, and in this case, a complex diagram on the left. There's far more detail I can't go into now, but you're welcome to view a YouTube presentation I've put at the bottom of this slide. There's a paper that goes into more detail, talking through the details. And basically, we use models to optimize placement of urban woodland for each various specific benefits, 8 specific benefits in this diagram. And then we can go on to assess secondary benefits of each placement option to hopefully identify an overall optimum. We've used this kind of approach to work with end users, so in consultation with the local authority in Birmingham, who are interested in targeting 4% increase in tree cover to help meet their net zero aspirations. To do this, we've developed new models. We've simplified our models to work at city scale for flooding mitigation and for noise mitigation. For example, the slide on the graphs on the maps on the right show woodland scenarios, an annual mitigation value, and with a focus on noise mitigation. And the top right map, the opportunity map, is optimized for noise mitigation and shows that very nicely that the economic value of that optimized solution is much greater than random allocation, and much more so than the present, much more benefit than we have the present day of tree coverage situation. Finally, to conclude, benefits of woodland, the earlier part of the presentation, direct evidence is limited, but urban woodland certainly performing similarly well to woodland in natural settings where benefits are better known. Riparian woodland, very beneficial. Trees benefit urban aquatic biodiversity, even if not near to water bodies. And street trees are a special case. They can provide multiple benefits for environmental health, but frequent street sweeping is certainly necessary to ensure that water quality benefits can approach those derived from parkland trees. Finally, a few points regarding decision support tools to help end users apply nature-based solutions. Very important that tools have up-to-date and relevant evidence on urban environmental response. And important to note that optimizing for multiple benefits is challenging at a city level. We need to consider the scale issues, which I mentioned in the previous slide, and the various models that we use for quantifying ecosystem functions typically use spatial land cover information in quite different ways. So transferring information between models and sort of achieving this optimal solution is complex. And not all models actually directly optimize NBS placement. So we have to think about how these models can better work. And it requires simple models, but simple models that also represent key drivers realistically. And I showed an example of that with water quality and riparian trees. So many thanks. Thank you for your attention today, and I welcome questions. Thanks to contributors from CEH and from outside listed here. There's the links to the projects that we've undertaken, and also a plug for a forthcoming special issue in Frontiers in Water, which I'm co-editing and which is sort of bringing together NBS at the interface between science and practice. Thank you very much.
Yeah, thank you very much, Michael. It's a very interesting presentation. I will request the attendees to leave their questions in the Q&A chat box so I can pick them up towards the end of the second presentation. So please leave your questions in the Q&A chat box with your name and affiliation if you want that to be read alongside your question. I would like to now introduce our second speaker, which is Janice Scheffler. She's a meteorologist and atmospheric modeler who have been looking at the human influence on the atmosphere, first by looking at the chemistry and dynamics higher up in the atmosphere, and now by looking at the quality of the air we breathe. So the very interesting presentation. I like to pass it over to Janice. Thank you.
Thank you very much, Prashant, and thank you for having me. Imagine you're in a big city. It's summer and it's sweltering hot. The city is full of people on foot and in a car, and as you walk along a road, you notice how loud the traffic is. Cars are honking, braking, and accelerating. The air is anything but clean, and it seems to be getting hotter and hotter. You long for a respite. Then you turn around the corner and see a park. The sight calms you down immediately. You escape into the park. The air is fresh, the noise is muffled, and the temperature seems bearable at last. You breathe in deeply. Now, this is what we're looking at with REGREEN, how nature-based solutions can improve living in a city. And this involves anything from collecting knowledge and evidence and to developing and testing tools, and also improving business models and raising awareness around nature-based solutions. We do that in close cooperation with the local communities as well, taking into account the specific needs that those communities have and the challenges they are facing. And we're looking into different co-benefits from nature-based solutions, as on water quality, as you've just seen from Mike's presentation, and also on water flow, biodiversity, heat, noise, and air quality, which I'll be showing you some results for now. So what we want to do is to quantify the monetary value of air pollution removal by urban vegetation. And we're starting off with our natural capital, which are the trees within a city or just a peri-urban area. So we start off with the existing urban and peri-urban vegetation and possible changes to them. We then we want to see what's the service they provide, so that is the pollution removal, and we can do so by feeding land cover maps of the urban and peri-urban vegetation into our atmospheric chemistry transport model, which is EMAP. And EMAP can calculate the dry deposition of those pollutants depending on the surface. So different surfaces will hold the pollutants better or worse. So for example, pollutants falling on trees will stay there much better than on a bare soil, for example. And so the good provided by this is the clean air, and we then quantify the health benefit we're getting from this. So we've got, we calculate the impact of PM2.5 on the mortality and mobility on the population using health functions for 4 pollutants, for PM2.5, SO2, NO2, and ozone. And I'll be focusing on PM2.5 in this presentation. You've already seen some results for the city of Aarhus in Mike's talk just now. So in REGREEN, we have got 3 cities we're looking at. That is Paris, Aarhus in Denmark, and a smaller city in Croatia, which is called Velika Gorica. I'll be mostly showing the results from Aarhus here. So this is one land cover map that goes into our model. We see where Aarhus is located at the sea, and we've got the urban area in gray here. So those are the settlements. And then we've got different types of trees. So we've got deciduous and coniferous trees, and also grassland, cropland within that area. And then next step is to make up some scenarios. So one is on the left-hand side to look at the effect of all the vegetation within the urban footprint. So the urban footprint is around like the urban area in that case, with a little buffer zone. And so marked, what you decolored fields here are all the vegetation within the city that we would be removing in this scenario. And on the right-hand side, we are just removing the trees, so the coniferous and deciduous trees within the urban area. And another scenario is where we remove selected trees in the peri-urban area. So if we remember the second scenario we had, where we had removed trees within the urban area, and we keep in mind the same area of trees that are in the urban area, we remove outside of the urban area, so in the peri-urban area. And we focus, or we prioritize smaller patches of woodland that are closer to the urban areas. And another scenario we have is an afforestation scenario, where we basically replace grassland and cropland within the urban area with trees. And these land cover maps we can feed to our atmospheric chemistry transport model, which is EMAP4 UK. This is a 3-dimensional atmospheric chemistry model with over 80 species, including ozone, particulate matter, nitrogen dioxide, second inorganic and organic aerosols. And what the model does, it uses emissions from emission inventories and then models the transport and the chemical changes of those pollutants, and then calculates the deposition, that is either dry deposition, just like falling out of the particles, or wet deposition, that is basically being washed out with the rain. And the model, so we give the model different surfaces for the different scenarios, so we can model the effect of different land covers on the deposition. The domain we're looking at for this project is bordered with this red box here, so it's not quite all of Europe, but we've zoned in on this region to include all our cities we're looking at. And I've done 5 model runs for the year of 2018. That is 1 reference run and 4 scenarios. And here are some results for looking at the whole area. Looking at the left-hand side, we've got the deciduous tree land cover fraction that we've changed. We've got the reference one, which is just the base one with the normal land cover as it is today. And then the test run is where we removed peri-urban trees. And on the 2 bottom plots here is the absolute difference between those and the relative difference. Now, if you look at the absolute difference on the left here, you see Paris. The effect on Paris you see very clearly. The effect on Aarhus up here is very small, so I'll be zooming in on Aarhus later a bit. So we see what we've changed here is we removed deciduous trees in the peri-urban area, and we can see that quite clearly. Now, looking at the right-hand side, it's the biogenic emission of isoprene, and the trees do emit isoprene themselves. So what we can see here is, so this is the emission of isoprene by vegetation is calculated interactively within the model. So what we can see here is that with less trees in a peri-urban area, we've got a lower emission of isoprene, as we would expect. And then looking at the surface concentration of PM2.5, again, looking at the Paris region, we see that there is an increase in the concentration of PM2.5 in the area where trees have been removed, but we can also see there is a bit of a bigger footprint there as well. Now we've done a validation for our model run and compared specific sites with observations, and the observations come from the European Air Quality e-reporting. Unfortunately, they did not have PM2.5 concentrations for August in the year of 2018. So we always validate with different pollutants, but for this study we are more interested in PM2.5. So Paris is another city we're looking at, and just to have a look at how well EMAP is doing in Paris, I've got two sites here. One is in the center of Paris, and one is slightly to the outside in Gonesse. And the observed values are shown in the shading here, and the model is shown in the colored line. And we can see that the variability and also the magnitude are well matched for both Gonesse and Paris Centre. And now looking at the results for Aarhus, and comparing two of our scenarios here. On the left-hand side, as a reminder, is the land cover map for this scenario. So we've removed trees within the urban footprint, and on the right-hand side is the other scenario we're comparing against. And we've removed trees in the peri-urban area. And as a reminder, it is the same area of woodland that has been removed in both of these scenarios. Now, looking at the change in PM2.5 concentration, here for the removal of trees in the urban and the peri-urban area, we see that the main effect of the change in concentration is within the area where the trees have been removed. So here in this scenario in the urban area, and in the other one in the peri-urban area, which is what we would be expecting. Now, looking at the average concentration change, we see that for the scenario 2, where we remove trees in the urban area, we've got a larger removal of concentration than for the other scenario where we moved trees in a peri-urban area. Now, the concentration change will also depend on the magnitude of the pollution itself. So if it's more polluted in the urban area here, then the removal of pollution can be larger there as well, just because of that. And then we also looked at the population weighted concentration change, and we see that this is larger both within the urban and peri-urban area for this scenario where we removed trees in the urban area, and that is related to the larger amount of people living in the urban area. Now, what we were interested as well in this study is to look at the monetary value this change in concentration provides. And what we've done here is we have the change in exposure to pollution, and we've converted this into a health impact metric using the report of the Committee on the Medical Effects of Air Pollutants in the UK, and also a systematic review on PM2.5 and mortality and hospital admissions. And this health impact metric is then being multiplied with values that are derived from the UK government's Green Book guidance on the cost of air pollution for policy approval. So these are quite robust values we're using in here. So the health savings adjusted to 2023 prices we're getting for the pollution removal scenario in the urban area is about 457,000 pounds. And for this peri-urban area, we've got removal that we've got 30,000 pounds. And yeah, so we've seen that there are health benefits from clearer air because of trees in city, and there will also be the co-benefits on well-being, heat, water retention, etc. We have still to do this health valuation for the other cities and scenarios looking at, and we also want to derive some per unit woodland pollution removal and health benefits for each of the cities, and also look at other land cover types. And yes, also other pollutants. And with that, I thank you very much.
Thank you very much, Janice. Very interesting presentation. I think we covered basically the both topics, which is very important in terms of the water and the air today. I would encourage the colleagues to leave their questions in the chat box. So we got a little bit of time to ask questions. Maybe I'll just start with Mike. So you've got a question from Alejandro, and they're asking that you mentioned that riparian influence on water quality is complex. Can you expand on this? What key considerations do we have to have in mind?
Yes, that's a good question. Riparian woodland is quite specific in terms of its effects, in that the shade from riparian trees and the cooling effect will reduce or suppress accelerated eutrophication. So those unwanted effects that we might see downstream in our larger rivers, which might start up in our urban small rivers, will be suppressed. So that's a good benefit. At a local scale, however, if we're interested more kind of narrowly in the context just of nutrient concentrations and nutrient fluxes, the effects of the riparian trees will mean that there's less biotic uptake of nutrients. So they might appear to have, well, in that respect, they will lead to temporarily to larger fluxes of nutrients further downstream. So this is the main, this is the main kind of complexity that riparian trees sort of bring about. Yeah.
Okay, thank you. And we got another one from Alejandro. He's asking about why even small or how small areas of sparse land so detrimental. Is it related to the soil erodibility or fine sediment or absorbed pollutants inputs?
Yes, that it's a very interesting finding, I must say. So this was related to the aquatic macroinvertebrates. So the data set that was used for this statistical analysis was on around 140 urban rivers. And we looked at the land cover in the basins draining at each of the locations in these rivers. And sparse land was rarely more than a few percent land cover share in those basins. So it's a very small amount. That's the first question, isn't it? Is how small, and how can it be so detrimental? Well, this is a difficult. This is quite a difficult question and an interesting one. The analysis was not a process-based analysis. It was an empirical statistical analysis. So we didn't look at mechanisms here. But I suspect Alejandro's right. It's related very much to soil erodibility and to sediments, fine sediments. Certainly, in a building site situation, you're going to have you're very much going to have an acute kind of situation where you lose sediments transported to rivers. So I think, yes, that would be the case. And also, I suspect we'll see the effects of legacy pollution. You know, if we're looking at derelict industrial sites, which we probably are in many cases, so that's a factor. And probably also, I suspect also it negatively would affect the habitats that the invertebrates need. For example, the ones that have an insect adult life cycle, the insect phase, and where that, you know, they are more mobile outside of the watercourse. So yes, lots of interesting aspects to the problems of sparse land.
Okay, fantastic. I think I've got a question for Janice. So Janice, it was a really interesting presentation. How accurately you think that the consideration of the green infrastructure could be accommodated within the models you have been using?
Sorry, that was a bit muffled. Could you repeat that, please?
Yeah, so the question was that how much, like how well these models could kind of stimulate the impact of the different kind of infrastructure types. So what kind of accuracy or the uncertainties you see actually in the, in the estimations against the actual kind of, the impact?
Of the pollution removed, or?
Yeah, the pollution, the particle removal, yeah.
I don't know, I think it's hard to know from like the real world, because as far as I know, it's very hard to study that in the real world. So there aren't really observations to compare it against. So I struggled to answer that precisely.
Yeah, that's fine. Yeah, and then how does this chemistry play a role in terms of when you're using a model with and without the chemistry? How much impact do they make?
So we did the impact of the chemistry? Yeah,
impact of the chemistry on the particle removal. So because some of the processes might reduce the concentration, and some of them could contribute actually to the the increasing.
Yeah, so for trees, for example, as I said in the presentation, some trees do emit particles as well. So isoprene, for example, that will depend on the tree species, but then also on the temperature. So that is modeled in there as well. Yeah, so we're taking that into account. But as we've seen for this one, the net effect was still a pollution removal. But we know from studies that there are some trees, especially eucalyptus, that has like a much higher emission of biogenics, where you would most likely just like have an increase in the concentration.
Okay, great. If anyone else have got any questions, can you please put in the chat box? So yeah, maybe I could ask one more from Mike. So Mike, what kind of challenges do you see actually when it comes to assessing the impact of the green infrastructure, especially from the water perspective?
I think, well, from our experience with the project work, I think what's been particularly challenging from the water perspective has been to represent, the very specific local conditions that can play a role. So it's hard to, well, it's hard to bring together all the necessary information to basically make a very thorough assessment. So we need to know a lot about the land cover, the condition of the land surface, the water sources of pollution, all kinds of very specific local details, and so we need basically to develop approaches that take away all of the requirement for that detail and are more simpler approaches that are more readily applied widely. It's difficult to do this kind of thing at a city level when you're talking about somewhere like Paris that Janice has been presenting. Really very large cities, it's a huge job to model those and assess those cities in detail. So we have to find simple ways of doing it. But those simple ways of doing it, we have to also be able to represent all the key, the key factors that policymakers and local authorities need to consider. So it's getting that balance. This is the main problem, I think.
Okay, great. Yeah, thank you. So I don't think that we have got any other questions at the moment.
There's a couple of questions here. I don't know if you can see them.
Someone in the chat box.
Yeah, in the Q&A. It says, please could I ask Janice about hospital admissions? Is there any specific data for air pollution related admissions to hospital in the UK?
Thank you. I've just been, so this is a part that my colleague Alice Fitch has been doing, and she just answered this to me, and so I'm just gonna repeat that for your sake. So for the UK, there are morbidity data at the local authorities, and those are linked to pollutants and health. That comes from the British Lung Foundation and from ONS. And then for Europe, we're not quite sure, and we've got partners at the University of Exeter who are doing looking into that. They will likely just look at life years lost, which is an indicator for premature mortality.
Okay, great. Yeah, and I could see that there is another one actually, which was for Janice as well, which is asked by Telagani. He's asking that is there any specific data for air quality related admissions to hospitals? I mean, in the UK.
Did I?
Air pollution related admissions to hospitals.
Yes.
Yeah, that's what we just discussed. There was another one for Janice.
Yeah, so there's another one which asks you, could you talk more about how the health impacts of PM 2.5 exposure were calculated for this work?
Yes, so again, this is more Alice's part of the job, but she said, so for the UK, there are population-weighted concentrations calculated for regions and for the UK and local authority level, and we've got metrics for that. And we also need the morbidity and mortality data, and then those health metrics are calculated from population-weighted exposure using a response function using developed by COMEP. So that's the Committee on all the Medical Effects of Air Pollutants.
Okay, fantastic. Yeah, good. There's no more, right, here, Charlotte? I can't see any.
No, it looks as though the Q&A box is not working very well.
Yeah, I think there was a little bit of delay in there.
Yeah.
Anyway, I think it was a fantastic session, and I really like to thank you both for your time and making this excellent presentation. And these topics are very relevant and very topical in the sense that there's a lot actually needed to understand and build that understanding about how the green infrastructure could help or what kind of benefit they could provide when it comes to the water and air. So I think with that, I would like to thank you both for the fantastic presentation. But before we close this session, I would like to make a little announcement about our next webinar. And so the next webinar is gonna be the I think it's webinar 18, right? So we'll show you the slides. But in the meantime, if you are not the member of the REGREEN network, so you could just simply visit the REGREEN website, and you can sign up actually to be a member there. We are also there on the LinkedIn and the Twitter. So I think it's called now X. So if you are there, then you can also follow your updates on that. Can we have slides? Sorry for the. Do we have the slides for the next seminar? Yeah. So the next one is gonna be quite again a very interesting set of presentations, and the colleagues are going to come from US. So I could see that they are having expertise in the air pollution green infrastructure modeling. So Professor K. Chung, you might have seen quite a lot of work coming from them from Cornell University. And we got Dr. Richard Baldauf. So he's from the US EPA. He's done a significant amount of work on the urban green infrastructure. And there has been a guidance actually he have been leading, and we have been drafting it for some time, which will be released actually at some point, so you can see the presentation around that work. So with that, again, thank you very much to both of our speakers, Michael and Janice, and thank you, Mark and Charlotte, for doing all the hard work in the background. And as I said, if you have any questions, please write to us on the REGREEN network. You can see that the email address there, which is info@regreem-network.org. And again, as I said, you can follow up on the social media platforms to know a little more update. So contact us if you are interested in any of the activities or wanted to get connected with the people working in this particular area, where we have got quite a lot of work done on developing some new resource page. So if you have time, just visit that page. But also you can submit your output there so that others can have access and they can benefit actually from your work, and you can benefit from their readings and application of your work into those particular areas. So yeah, with that, I would like to thank everyone again and see you in the next webinar.